So here we have properties of quadrilaterals, and quadrilaterals are really defined as shapes that have four sides. And so here I've listed three main ones, or the three basic ones that you will see for geometry: the square, the rhombus, and the rectangle. And so for the square, all angles are equal, which means that they're 90 degrees in measure. I'll later tell you about certain formulas that are really handy. For instance, n minus 2 times 180. So if you have a square, 4 minus 2 is 2 times 180 is 360 degrees. That formula is used to find the sum, basically the sum of all the interior angles in a certain polygon. And so obviously these are quadrilaterals, which means that the sum of all interior angles will be 360 degrees. And so this being, having all angles equal, 360 divided by 4 is 90 degrees. And so square has equal sides, as we all know, and its opposite sides are parallel. And this is a big concept, and you will see this in the rhombus and the rectangle as well, because as we discussed before with the transversal and the parallel lines being cut by the transversal, there's certain rules that apply with angles being equal. And so you can see those questions about angles if you really end up extending a line, which is really the transversal, if you see it through that perspective. And then you have diagonals bisecting each other at 90 degrees. And if these diagonals are equal in length, that means that these bisect each other, which is again an important terminology to understand. Bisect meaning that this diagonal is dividing the other diagonal into two equal segments. Now moving on to the rhombus, we have, again, like the square, a rhombus has sides that are of equal length, and so its opposite sides are also parallel. Again, using that same concept that if you were to extend these two sides and then extend this up here and down here, you would see that a transversal cutting two parallel lines, a figure like that would emerge, and then you can apply those rules. And so diagonals again bisect each other at 90 degrees. However, unlike a square, a rhombus has diagonals that are not necessarily equal in length. And so these are some important properties, and you also have to understand that opposite angles are equal in a rhombus. So if this is 60 degrees, this is 60 degrees. Knowing that the sum is 360 degrees, you would subtract 120 degrees from 360 and then divide the result by 2 to find the other measure of each of the other two angles. And so those are the basic concepts you should know for a rhombus here. And then moving on to the third one, we have a rectangle. And so for a rectangle, really all angles, again, like a square, are 90 degrees. And opposite sides are equal. However, unlike a square, which has all sides being equal, a rectangle has only sides that are opposite, which are equal. And diagonals are also equal in length for a rectangle, which again implies that these are being bisected. If you think through this, you can really say that a square is, all squares are rhombuses, all squares are rectangles, but the converse is not necessarily true. If you think about it, when I say that all squares are rectangles, what I mean is that all these properties here for a rectangle are applicable for a square, but the converse is not necessarily true, because if you just look at a rectangle, you know that it's not all of its sides are equal, which means that a specific rectangle like that cannot be a square. So these are the three basic types. I will be covering the parallelogram and the trapezoid in the next session. Thank you.